In a laboratory experiment, a 200-gram air-trag glider and a 400-gram air-trag glider are pushed toward each other from opposite ends of the track. The gliders have Velcro tabs on the front and will stick together when they collide. The 200-gram glider is pushed with an initial speed of 3 meters per second. The collision causes it to reverse direction at 0.4 meters per second. What was the initial speed of the 400-gram glider? So this is the situation that we're imagining. We have a 200-gram glider that's pushed on a track in one direction, a 400-gram glider that's pushed in the opposite direction. We're not told which direction is which, and it really doesn't matter very much. So we're going to go ahead and go with our standard convention for our x and y coordinates. If it turns out that these directions were flipped around, basically it would just be a negative sign on the velocities. So arbitrarily we'll pick glider 1 to be moving to the right, glider 2 to be moving to the left, and we're told that the 200-gram glider, the first glider, reverses direction, and so it'll actually be moving to the left at the end. This is what we're trying to find. Since we have a collision here, we have to consider the conservation of momentum. If we consider both gliders as the system together, then any forces between them will be internal forces and won't change the overall momentum of the system, and thus it will be conserved. And so we can look at the momentum of 1 initially and the momentum of 2 initially and compare that to the final momentum of this conglomerate, and we'll see be able to use that information to find the initial speed of the 400-gram glider. So we want to say that the total momentum at the beginning equals the total momentum at the end. Again, because we're considering the system to be both carts, then all of the interaction between the two carts are internal forces, and so the momentum will be conserved. In this situation as well, if we consider that the cart would be on the track, the cart would also feel gravity downwards, and it would feel a normal force upwards. So those are external forces that it would feel, but the normal force and the gravity would balance each other out, and so there'd be no net external force in this situation. Now we know that the initial momentum is comprised of the mass of the first glider and the velocity of the first glider, and the mass of the second glider and the velocity of the second glider. We know that the final momentum, the two gliders are moving together. They're one unit at that point, and so there's a total amount of mass that's moving, and that total amount of mass is moving at one velocity. One thing to point out here is that momentum is a vector, and it has to have a direction. And so we said that glider 1 was moving to the right. We can presume that glider 2 was moving to the left if together after the collision they're moving to the left. And if you want to do that, you can put in a negative sign here to show that the momentum of glider 2 is to the left, is in the negative direction. And in that case, you'll find V2, an amount for V2, and you'll have to know that that amount is the speed, and we've already counted for the direction. If you want to do it that way is fine. You can also leave it as a plus, because this is a vector and this is a vector, and basically if we solve it this way we'll find that V2 has to be a negative number, meaning that it is a velocity that's pointed to the left, and either way we're seeing the same thing mathematically. This way we're not assuming that we know the direction of V2, and so we'll let it be what it needs to be. Now that we have an algebraic expression for our conservation of momentum, we can plug in. We know the mass of the first glider, and we know that its velocity is 3. We know the mass of the second glider, but we do not know its velocity. And we know that the mass of the conglomeration of the two will be 600 grams, and we know that it's moving to the left. We know it's moving to the left because it's the reverse direction of glider number 1, and it's moving at 0.4 meters per second. And to the left is why we put a negative sign there. And so we can simplify. When we solve for V2, we find negative 2.1 meters per second. And this is what we expect. It's a negative amount, so the first glider had to be moving to the left, which makes sense. It had to be moving to the left so that it could drive the whole system to the left. We know that it had to be around the same size as the other glider, but since this is for the heavier glider, this glider is twice as big, so it can't be going, has to be going a little bit slower than the lighter cart, but not very much slower, because they're not moving very fast at the end. And so this is the right range for that velocity.